What I am going to talk to you about today is the common adulterants in different foods. Dear students, myself Dr. Digna Varghese. My talk is divided into two parts. That is, in part 1, common adulterants used in different foods. Part 1 includes adulteration, adulterants, milk and milk products, vegetable oils, chili powder, and in part 2 cereals, coffee and tea powder, beverages, that will explain in part 2. So let us begin with part 1. Adulteration. The addition or subtraction of any substance to or from food so that the natural composition and quality of food substance is affected. Adulteration is either intentional by either removing substances to food or altering the existing natural properties of food knowingly. Unintentional adulteration is usually attributed to ignorance, carelessness, or lack of facilities for maintaining food quality. Incidental contamination during the period of growth, harvesting, storage, processing, transport, and distribution of foods. Adulterant. Adulterant means any material which is or could be employed for making the food unsafe, or substandard, or misbranded, or containing extraneous matter. Types of adulterants. Type 1, intentional adulterants. Substances added to the food items, that is, may be sand, marble chips, stones, mud, other filth, talc, chalk powder, water, mineral oil, and harmful color. Incidental adulterants, pesticide residues, droppings of rodents, larvae in foods, etc. Metallic contaminants, arsenic from pesticides, lead from water, effluent from chemical industries, tin from cans. Food is declared adulterated if a substance is added which depreciates or injuriously affects it. Cheaper or inferior substances are substituted wholly or in part. Any valuable or necessary constituent has been wholly or in part abstracted. It is colored or otherwise treated to improve its appearance, or if it contains any added substance injurious to health. For whatever reasons, its quality is below the standard. Adulterated food is dangerous because it may be toxic and can affect health, and it could deprive nutrients essential for proper growth and development. I think everybody has heard about the common adulterants present in milk and milk products. As all are aware about the common adulterant and the cheaper adulterant used in the milk is water. The presence of water is detected by putting a drop of milk on a polished slanting surface. Here we can see from the first figure that water can be detected by placing a drop of milk on a slanting surface. The drop of pure milk flows slowly, leaving a white tail behind it, whereas milk adulterated with water will flow immediately without leaving a mark on the surface. So the figure, this is representing the adulterated milk, and the first one is representing the pure milk. this is an easier method we can use in our home also. By adding milk, the quality of the milk is lost and we do not get proper benefit from the adulterated milk as that of the pure milk. Second adulterant used in milk is detergent. So shake 5 to 10 ml of sample with an equal amount of water. Lather indicates the presence of detergent. That means take 5 to 10 ml of the sample with an equal amount of water. Shake the contents thoroughly. If the milk is adulterated with detergent, it forms dense lather. Pure milk will form very thin foam layer due to agitation. This is the figure for the picture for the adulterated milk, and this is the picture of the pure milk. If detergent is added, we take 10 ml of milk and 10 ml of water is added to this and shake well, and if lather forms densely, that means it is adulterated with detergent. If it is not, only a thin foam layer is present in that sample, that is not adulterated, that is a pure milk. This also we can use in our home to test whether detergent is present in the milk. Next common adulterants in milk and milk products is starch. Detection of starch by add a few drops of tincture of iodine or iodine solution. Tincture of iodine is or iodine tincture or weak iodine solution which is act as antiseptic. It is usually a 2 to 7% elemental iodine along with potassium iodide or sodium iodide dissolved in a mixture of ethanol and water. How we can detect starch in milk and milk products? For example, we can use a test with using iodine tincture. The formation: boil 2 to 3 ml sample with 5 ml of water, cool and 2 to 3 drops of tincture of iodine. Formation of a blue color in the presence of starch. In the case of milk, addition of water and boiling is not required. If we are using milk products, boil 2 to 3 ml of sample and add 5 ml of water within it. Cool, then add 2 to 3 drops of tincture of iodine. Formation of blue color indicates the presence of starch in that particular sample. But when we are using the pure milk, we are adding tincture of iodine to this particular milk. There is no blue color that indicates the sample is not adulterated with starch. So iodine solution is easily available in the medical stores. So this test can also used in our home. Next common adulterant used in milk and milk products is synthetic milk. What is a synthetic milk? Synthetic milk is made by adding white watercolor paint, urea, oils, detergent, alkali, etc. that mix together to form synthetic milk, which is just like the pure milk. How we can test whether this synthetic milk is added to our pure milk? That can be used by tasting or touching the synthetic milk. So this test is known as sensory evaluation quick test. Synthetic milk gives bitter taste after tasting. If it is adulterated, the pure milk is adulterated with synthetic milk, it gives a soapy feeling on rubbing between the fingers. That means it is a sensory evaluation quick test. Synthetic milk has a bitter after tasting. It gives a soapy feeling on rubbing between the fingers. When we are heating the sample, the color changes to yellow. That will also indicates the presence of synthetic milk in the pure milk. Another test is used for the presence of synthetic milk is test for protein. That is, the milk can be easily tested using urea strips. The color chart in urea strips helps to arrive at the quantity of urea present in the milk. Urea strip is a biostrip based on enzymatic activity. Synthetic milk, we are adding pure urea to this synthetic milk. So we can easily done the test if urea is present in or not, that by using a simple urea strips. Urea is the product of decarboxylation of amino acids. We know amino acid is the monomer of protein. That means protein is the polymer of alpha amino acids. If we are using this test for protein, that means the amino acid urea is the product of decarboxylation of amino acid, we will get urea. But synthetic milk contains urea in the pure form. So we can easily done this method by urea strips. Hydrolysis of urea. Hydrolysis means urea reacted with water. In the presence of urease, it will decompose into carbon dioxide, ammonia and water. The formation of ammonia alkalizes the medium. Therefore, the pH is shifted from 6.8 to 8.1. That means the orange color changes to red, magenta, pink. That means here urea negative, urea is absent here, but when urea is present, this color changes to magenta or pink. This is the urease biostrip. When we are adding 1 drop of milk here, if it is adulterated with the synthetic milk, the presence of urea is here. The conversion of urea into water and ammonia and carbon dioxide, it will immediately give magenta color to the strip. So we can easily identify whether the synthetic milk is adulterated with, pure milk is adulterated with or by synthetic milk. Adulterant urea can be tested in another way. Take a tablespoon of milk in a test tube, add half teaspoon of soybean or arha powder, mix up the contents thoroughly by shaking in the test tube. After 5 minutes, dip a red litmus paper in it. Remove the paper after half a minute. A change in color from red to blue indicates the presence of urea in the milk. Take a red litmus paper and to the tested solution, it converts to blue color. That means urea present in the milk. Another adulterant used in milk is glucose or invert sugar. That is tested by using a diacetyl strip. Take a strip of diacetyl strip and dip into the milk for 30 seconds to 1 minute. If the strip changes the color, then it shows the sample of milk contains glucose. If there is no change in color of the strip, then glucose is absent. Glucose inverts sugar syrup is added to the milk to increase the consistency and taste. If we are adding so many chemicals to the milk or so many adulterants to the pure milk that its sweetness will lost. So by the addition of invert sugar or glucose is added to the milk to increase its consistency as well as its taste. By using a dielectric strip and dip into the adulterated milk, it will give a color change, that is pink color. That means the glucose is present in the sample, and the pure milk show there is no such color. Another common adulterant used in milk and milk products is Vanaspadi or margarine. Take 3 ml of milk in a test tube, add 10 drops of hydrochloric acid, that is HCl, mix 1 teaspoonful of sugar. After 5 minutes, examine the mixture. The red coloration indicates the presence of Vanaspadi in milk. We are taking milk in a test tube, add 10 drops of hydrochloric acid to this and 1 teaspoonful sugar in it, and after my 5 minutes examine the mixture with using the presence of Vanaspadi is in the milk. It will turns the color to red, that is it is the adulterated milk. This is the pure milk. Formalin is also used as the adulterant in pure milk. Why formalin is used? It is used to enhance the life of milk, and thus this formalin is added for preservation purposes. Also, we know formalin is an aqueous solution of 37% aqueous solution of formaldehyde, that is HCHO. This solution is used as an antiseptic, disinfectant, and especially today as a fixative for histology, the study of tissues under the microscope. Formalin can be tested by taking 10 ml of the milk in a test tube and add 5 ml of concentrated sulfuric acid, that is H2SO4, from the sides of the wall without shaking. If a violet or blue ring appears at the intersection of the two layers, then it shows the presence of formalin. Here we can see the intersection of the two layers. There is a ring, violet or a blue ring, that is indicates the presence of formalin. When we are taking 10 ml of the sample, to this 5 ml concentrated sulfuric acid added without shaking. If shaking occurs, there is no formation of the ring. So without shaking, concentrated acid added through the sides of the test tube. If a violet ring or blue ring appears at the junction of the two liquids, this indicates the presence of formalin in the sample. Next common adulterant used in milk is ammonium sulphate. Ammonium sulphate used to indicate or the presence of sulphate in the milk, which increases the lactometer reading. So always use ammonium sulphate to increase the lactometer reading. Test for ammonium sulphate in milk. First one is take 5 ml of hot milk in a test tube. Add a suitable acid, for example citric acid. The whey obtained is separated and filtered. Take the whey in another test tube and add 0.5 ml of 5% barium chloride solution. Appearance of precipitate indicates the presence of ammonium sulphate. When barium chloride is added to the whey, it will give barium sulphate that will precipitate in the test tube. That indicates the presence of ammonium sulphate. Another test for ammonium sulphate is take 5 ml of milk in a test tube, Add 2.5 ml of 2% sodium hydroxide solution. Then 2.5 ml 2% sodium hypochlorite solution, NaClO, that is, and 2.5 ml of 5% phenol solution. Heat for 20 seconds in a boiling water bath. If bluish color turns to deep blue, it indicates the presence of ammonium sulphate. We can take 5 ml of milk in a test tube, add sodium hydroxide, add sodium hypochlorite, and add phenol. Within 20 seconds on a boiling water bath, the color changes from blue to deep blue. That indicates the presence of ammonium sulphate. However, in the case it turns to pink, it shows the sample is free from ammonium sulphate. Next one is the presence of hydrogen peroxide as adulterant in milk. First, we take this 5 ml milk sample in a test tube, add 3 drops of paraphenylenediamine and shake well. Change the color of the milk blue confirms the milk is adulterated with hydrogen peroxide. Another test for hydrogen peroxide is take 10 ml milk sample in a test tube, 10 to 15 drops of vanadium pentoxide reagent and mix it. Pink or red color indicates the presence of hydrogen peroxide. First test, samples milk with paraphenylenediamine, shake well, color changes to blue, it indicates the presence of hydrogen peroxide. Second test, take the milk sample, to this 10 to 15 drops of vanadium pentoxide V2O5 reagent, add and mix. Pink or red color indicates the presence of hydrogen peroxide. Another test for sugar, that is, take 3 ml of milk in a test tube, add 2 ml of hydrochloric acid, heat the test tube after adding 50 mg resorcinol. The red coloration indicates the use of sugar in the milk. If you are taking the milk sample in a test tube, 2 ml of hydrochloric acid and heat the test tube, to this solution 50 mg resorcinol is added, so that we get red color in the presence of sugar. Another test for the presence of detection of mashed potatoes or sweet potatoes and other starches in ghee or butter, that is also by using tincture of iodine. We are taking the half teaspoon ghee or butter in a transparent glass bowl. 2 to 3 drops of tincture of iodine is added to this. Formation of blue color indicates the presence of potatoes or mashed potatoes or sweet potatoes and other starch present in the milk products. Here ghee or butter is used as the sample. This test is also used for pure milk that we are already seen. Sodium bicarbonate or neutralizer act as adulterant in milk. To test this sodium carbonate is present in the milk is by take 3 ml milk sample in a test tube and add 5 ml of rectified spirit to it. Then add 4 drops of rosalic acid. The structure of rosalic acid is shown here. Take the sample milk, then rectified spirit and rosalic acid is added to this, and the appearance of red color or rosy red coloration indicates the presence of sodium bicarbonate or neutralizer present in the milk. Another adulterant is boric acid. Take 3 ml of milk in a test tube, add 20 drops of hydrochloric acid, shake the test tube well To this test tube, an yellow strip is added. Yellow strip is made by dipping strips of filter paper in an aqueous solution of turmeric and dry it. Then we will get yellow strip, and yellow strip is dipped into the mixture of milk sample and also the 20 drops of hydrochloric acid solution. Dipped this into for 1 minute. After that, the color changes to red. That will indicate the presence of boric acid. And again we add ammonia solution, 1 drop of this coloration. It will changes to green. This also indicates the presence of boric acid present in the milk. Sodium carbonate, boric acid, hydrogen peroxide and formalin, detergent, synthetic milk that are added to the milk. Now we are testing removal of fat from the milk. That also an adulteration method. That removal of an important substance from the sample. That is, removal of fat is testing here. That is tested by the lactometer reading. That will indicates above 26. The value indicates the presence of removal of fat from the pure milk. The milk will apparently remain thick. Now we are discussing the next topic, that is adulteration in vegetable oils. First we are considering the coconut oil. Detection of other oils present in coconut oil. First test is this. The method is like that. Take coconut oil in a transparent glass. Place this glass in a refrigerator for 30 minutes. Do not keep inside the freezer. After refrigeration, coconut oil solidifies. If pure coconut oil is solidifies, it is in a consistent layer. If coconut oil is adulterated with some other oils, it will give 2 layers or in a separate layer. The other oil remains as in a separate layer and coconut oil as the solid form after 30 minutes. So we can easily tested by the use of a refrigerator whether our oil is adulterated or not. Another adulterant used in vegetable oil is TOCP, that is triorthocrysyl phosphate. The structure of triorthocrysyl phosphate is shown here. It is a colorless viscous liquid, although commercial samples are typically yellow in color. It is used in the manufacturing of for lacquers and varnishes and as a plasticizer. It is a toxic substance that we can see it is used in the manufacture of for lacquers and varnishes as plasticizers. It is a toxic substance that can cause neuropathy, paralysis in the hands and feet, and or death for humans and animals alike. It can be ingested, inhaled, or even absorbed through the skin. Its orthoisomerase, that is this one, is notoriously known as a source of several delayed neurotoxic outbreaks across recent history. So it is a highly toxic substance that is used as adulterant in vegetable oils. The testing method is that take 2 ml of the sample oil, add a little amount of yellow butter, that is solid. Immediate formation of red color indicates the presence of TOCP. That we can test within our home. A simple test: take the 2 ml sample oil, add a little amount of yellow butter in the solid form also. Immediate butter is taken in a vessel or a plate and add 2 ml of the sample oil to this. If it is pure, the yellow color remains. If it is adulterated with the TOCP, the color changes to red. Another one is proper winterization of refined winterized salad oils. That winterization is the type of fractionation, also known as fractionate crystallization, the general process of separating the triglycerides found in fats and oils using the difference in their melting points, solubility and volatility. Winterization is an oil refinement technique commonly used in biotechnology. That is, winterization is used to refine the oil in salad dressings, mayonnaise, cooking oils like sunflower oil and botanical oils. Food products containing non-processed oils such as fats and waxes with higher melting points will crystallize in refrigeration temperature. This precipitation could result in products like salad dressing separating during cold storage. Actually, we are using winterization to avoid this process. The testing method is take 100 ml of the sample oil in a bottle, cork tightly and seal with paraffin. The bottle is completely submerged in bucket containing finely cracked ice, and water is added until it rises to top of the bottle. The bucket is kept filled solidify with ice by removing any excess water and adding ice when necessary. After 5.5 hours, remove the bottle and examine the oil. If it is properly winterized, sample will be brilliant, clear and limpid. So we can see here refined winterized salad oils is used for salad dressings. Another adulterant used as in vegetable oil is prohibited color is used. That is, if any color is added to the vegetable oil, that can be tested in a lab by using the sample in a test tube and add 5 ml concentrated hydrochloric acid to this. Shake gently, let it stand for 5 minutes. After 5 minutes, if any color separate the upper layer of the solution, it will indicate the color is added to the particular oil. Next one is coconut oil is adulterated with any other oil. That is, we are already seen, that is, the sample is kept in refrigerator, not inside the freezer. The coconut oil solidifies, leaving the adulterant as a separate layer. Mustard oil is adulterated with argemone oil. That is, argemone seeds is just like mustard seeds, that is adulterated with argemone oil. We can separate this or two oils by gas chromatography techniques and by the use of mass spectrometer. This is a hyphenated method, GCMS. By the use of GCMS instrument, we can separate these two oils. If argemone oil is present, there is 2 gas chromatogram or separate gas chromatograms will get instead of 1 gas chromatograph for pure mustard oil. Turning our attention now to different adulterants in chili powder. First, we are using a testing method for the detection of artificial or water soluble synthetic colors in chili powder. The testing method is sprinkle chili powder on a surface of water taken in a glass. Artificial colorants are present will immediately start descending in color streaks, that is water soluble artificial colors that will be descending in color streaks. So adulterated chili powder is like this, and the pure chili powder is present on the surface of the water taken in the glass tumbler. Next test is used for the sawdust in chili powder. Add the chili powder is taken in a glass tumbler. Add sample to water. The sawdust will flow at the surface of the water while chili powder will settle down in the bottom. This is the sawdust adulterated chili powder. This is the pure chili powder. Next method is to detect brick powder or salt powder or talc powder in chili powder. Take a teaspoon of chili powder in a glass of water and examine the residue. Second step, when the residue is rubbed and if any grittiness is felt, it indicates the presence of brick powder or sand present in that particular sample. When the white residue is obtained, that is rubbed, soapy and smooth feel indicates in the presence of soapstone. What is soapstone? Soapstone, also known as steatite or soap rock, is a talc schist which is a type of metamorphic rock. It is composed largely of the magnesium rich mineral talc. Another method is used to find the brick powder is to a little of the powder of chili, add small amount of concentrated HCl and mix to the consistency of paste. Dip the rear end of the matchstick into the paste or a glass rod we can use in the lab and hold over the flame. Brick red flame color due to the presence of calcium salts in brick powder. Brick powder, actually one of the component in brick powder is lime, so it is a salt of calcium. So we are using flame test here to identify the presence of calcium salts in chili powder. That will indicates the presence of brick powder, that is the chili powder adulterated with brick powder. Detection of malachite green in green vegetables like bitter ground, green chili and others. Malachite green is a green dye, that is burnt dye. Method is like that: take a cotton piece soaked in water or vegetable oil. Conduct test separately. If it is taken in a water, dipped in water or in oil. Rub the outer green surface of the small part of the green vegetable chili. If the cotton turns green, that will indicates the presence of malachite green in that particular sample, that is adulterated with malachite green. The chili is adulterated with malachite green. Here in this picture we can see the pure chili. That brings me to the end of my part 1 presentation. Thank you for your attention.